We want to talk about problem number 12 in the homework, as several of you have asked me the question. So basically, we are looking for the intervals of like increasing, decreasing, and local min, local max. So you are going to use the first derivative. My function is 2x plus 4 over x. So let's try to do the calculation here. Problem 12, it was, my bad, I'm sorry. It's 2x plus 4 over 6. I'm looking for increasing, decreasing, local min, local max. So once we get started, it shouldn't be too hard to finish the rest. So what we have is this function. Therefore, I want to find the derivative so I can discuss increasing, decreasing, local min, local max, all of which can be identified with first derivative. So the 4 over x is 4 times x to the negative 1. Hence, the derivative is negative 1. Move to the front. Keep your 4. The x to the power of negative 1 minus 1, negative 2. So it's 2 minus 4 over x squared, which is x squared. 2x squared minus 4, which is twice of x squared minus 2 over x squared. So it's 2x plus root 2, x minus root 2, x squared. So this is my derivative. I'm going to look for this being greater than or less than 0. Even though it's a division, I still want every piece to be factored, so I can set every piece to be 0 and get my answer. So if I set every piece to be 0, my pieces are 1, 2, 3, 4, 4 of those. 2 doesn't really give me a solution. X plus square root of 2, this term is going to give me x being negative root 2. And this term gives me x being positive root 2. This term gives me x being 0. So there are 3 points I'm going to put on the number line, which is going to affect my answer. Once I found those, I'm still trying to discuss increasing, decreasing, so I need to have the sign of the first derivative. Those are the points where my first derivative would be 0 or have a denominator being 0. All I need to do is to test values in those 4 intervals formed because of the 3 points. This is like negative 1.4. This is like positive 1.4. So I'm going to have negative 2, negative 1, positive 1, and positive 2 as my expression. Quite a few of you might have missed the 0, right? Make sure you include that because it's going to make a natural cut on your interval, even your function is not defined there. So that's something should be marked on the number line as well. So once we got that, what we have is f prime of negative 2, f prime of negative 1, f prime of 1, and f prime of 2. You can do the discussion by covering the sign and plug in negative 2. If you look at this expression, it's 2, which is positive. Negative 2 plus that is negative, negative 2 minus that is negative, negative 2 squared is positive. So just to summarize what I said, it's positive, negative, negative, and negative squared, hence positive. So it's greater than 0. Let's do that discussion again. If I plug in negative 1, it's positive here, it's positive, it's negative, it's positive. So what I said was positive, positive, negative, positive. So it's less than 0. You can continue your discussion the same way, and you will be able to identify this is going to be positive, it's going to be positive, negative, positive, since less than 0. If you plug in 2, every term would be positive, so you end up with that. So the general line of way of thinking is first derivative greater than 0, so your function goes up. Function goes down because derivative is negative, it goes down, it goes up. Therefore, if you are looking for the increasing interval, it's from negative infinity to negative root 2 combined with root 2 goes to infinity. If you're looking for the decreasing interval, it's negative root 2 to 0 combined with 0 to root 2. If you're looking for local maximum, it happens at x being negative root 2. If the problem asks for the function value, you're going to plug it into the function to figure it out. If you're looking for local minimum, it's where it changes from decreasing to increasing, hence it's going to happen at x being root 2. It's going to be the function value find out by plugging root 2 into the function f. So this should help you to address problem number 12 in the worksheet. Your problem might look slightly different. I'm not 100% sure of that, which would affect the actual numbers in your calculation. But this is a general idea.